As one of the flagship robotics research conferences worldwide, the IEEE RSJ International Conference on Intelligent Robots and Systems brings together an international community of researchers, educators, and world-leading roboticists to explore the frontier of science and technology in intelligent robots and systems. In this 35th anniversary event of its history, IROS 2022 will explore a wide range of topics from assistive and social robots to future autonomous systems to the philosophy of robotics research and so much more. And you can catch it all here on IROS TV. Welcome to IROS 2022, set in the cultural capital of Japan, Kyoto. We are thrilled to have the robotics community back together again to share ideas and advances in the field. Over the next week, we'll hear about the latest developments in robotic applications and technologies that impact many aspects of society. We'll also be visiting organizations from around the world carrying out innovative work in robotics and systems research. Today, we get an overview about the highlights of this year's conference with General Chair of IROS 2022, Professor Ma Shugen. We'll take a look at the latest work from the Robotics Engineering Department at Worcester Polytechnic Institute and the Human Augmentation Research Center at the National Institute of Advanced Industrial Science and Technology. Hear from the renowned roboticist Professor Toshio Fuda about the co-evolution of human and AI robots. Find out about the role of assistive robots in the care of people with mobility limitations. And finally, we ask you, the attendees, what you're most looking forward to at the conference. As you can see, we have a packed show for you, so stay tuned for our first interview. You're watching IROS TV. Joining me now is Professor Ma Shugen, the General Chair of IROS 2022. Thank you for joining us today.
Thank you very much.
After 2 years of hosting IROS online, why was it important to hold it in a traditional in-person conference?
Of course, to learn something, we can through the network. Virtual is okay. However, for deep discussion, we find a new topic. We need to talking face-to-face, in person. It's very important. Many researchers recognize that. That's why we try our hard to have the conference in person, held in Kyoto.
And I believe the theme of this year's conference is Embodied AI for Symbiotic Society. Tell us more about this.
One thing, of course, you can see, a lot of technology is, for example, is image recognition and auto-drive medicine. However, for next technology, what is important? Not only the software, it must be important to really to action with the society. Then what it needs should be hard body. That is why embodied AI. Then we can more bright application and also serve to our society.
This year marks the 35th anniversary of the IROS. What's happening here at the conference to highlight this monumental achievement?
For 35th anniversary, we have forum, right? We start to consider for 35 years what robot technology is really is helpful to our society. We have two keynote speakers. One is assistive, robotics, and one is autonomous drive. You see, I think it will be next generation with AI. Really make automobile is, driving on the road autonomously, right? I have two keynotes today. Of course, we have more. The technology is like the SLAM is really, really workful to our society. Another one, we have the forum for women. Therefore, we need more female researchers involved, more younger to involve our society, make the society more careful. Not only male researcher, the more female is very important. We also celebrate their contribution.
I love that.
Yes.
Thank you for sitting down with us for this interview.
Thank you.
Now, for the first of our visits to organizations, let's head to Massachusetts. WPI Robotics Engineering has been on the leading edge in combining fundamental robotics research and relevant applications with societal impact, and in integrating research and education through project-based learning.
The Robotics Engineering program was established in 2006 by the department heads and interested faculty members of computer science, mechanical engineering, and Electrical and Computer Engineering at WPI. It started as a pioneering undergraduate degree program, but in 2009, the master's and PhD programs were also added. After 14 years of development, the Department of Robotics Engineering was established on top of the program as the first such department in the nation.
There's a huge opportunity for the Robotics Engineering Department here at WPI. We really focus so much on this idea of combining academia and industry working together to solve real-world problems and really understanding this idea of theory and practice.
We're all very excited and inspired to make more impactful contributions to the world through robotics.
Remember, you can watch IROS TV here at the Kyoto International Conference Center. Find us on the IROS 2022 website and on social media. I'm now joined by Professor Toshio Fuda, the former president of IEEE. Thank you for joining us.
Thank you very much to invite me here. I'm so honored to be here.
Thank you. Can you introduce the Moonshot R&D project? What are you trying to achieve?
In my part is a moonshot goal number 3 on AI and robotics. This is my kind of goal. So we have a kind of a program to make such a kind of AI and robot for the future, aiming at 2050. So now more 30 years later, so society will be changed in that time. So based on such a kind of analogy of such a John F. Kennedy, we are going to moon in 1960, okay? To the end of the 1960, we should go to the moon, like such a challenging, okay? We are taking such a kind of word, moonshot, like that. We'd like to make a robot, which kind of working, serving, and also have a life together with you, and also the robot will survive with you from cradle to grave for your life.
Wow. What are some of the underpinning technologies required to achieve this goal by 2050?
Yes, of course, basic robot technology, including such an element-wise, such a kind sensor actuator, that kind of or material-wise too. More important, AI intelligence robot. How they can do that? One of them is such a kind of, say, co-evolution technology. Second is a kind of self-organization technology. 2 is very important. Co-evolution is something like robot. We can make a robot very intelligent, try to with AI, so how we can do that? Then human also learn from AI robot, okay? So that come back to such a human. Human also give the robot here like that. The robot give a kind of human influence. So that's a kind. They have a kind of closed cycle here. It is very interesting, okay? Yeah. This is a kind of co-evolution.
And why will our lives depend more and more on AI and robotics? And should we fear the advances in AI and robotics?
Then robots learn many things by themselves, get the information from environment, sensing, then they understand the kind of meaning of the kind of information, make a plan what to do, then make an action like that. So this is a kind of autonomous system. Autonomous system is different from the programmed robot, like industrial robot today. So that we need such an autonomous, because I don't want to teach them what to do, okay? I don't want to teach one by one. Go to the left, right, left, right. So we try to have a more intelligence here, so that they have to learn, accommodate with such a human, okay? That's nice. So that a robot and human is such a good, wise interaction. That's great.
Yeah, almost frightening, but again, it's like raising a child.
Yes, yeah. That's important. As you said, you give us such a good point.
Oh, thank you.
Education is very important, right? So it's a kind of educated by each other.
And how can AI and robotics help address some of these societal challenges of the future?
Now today, we are facing such a mega trend problem, such a kind of aging society, because of lack of the human labors, maybe robot take care of such as senior people, or many things, okay?
So what are you most excited about regarding the future of AI and robotics?
I want to use that robot for myself.
For yourself.
This is the most important thing, right? Yeah. So good. I can test them, such a kind of thing. I can try to enjoy my life with such a robot. Means any other people also enjoy that. I want to deliver such a robot to everybody in the world. Share like people, US, my friend, also people, other country, like even kind of people in the desert. This is a futuristic thing, and robot have to be accommodated with human in a way to save your life too also. That's a kind of. Thank you very much.
Thank you so much for joining us.
Yes.
Now over to Chiba City in Japan. The Human Augmentation Research Center is a multidisciplinary collective of scientists, engineers, and researchers developing novel technologies and methodologies in the emerging field of human augmentation. The team focuses on wearable sensors, VR devices, and digital modeling to improve human health and performance.
In our research center, we focus on 3 application fields: sensing and digital human modeling and intervention of the human and environmental technologies.
Here we have been developing MR Cube wear and mannequin for improving and helping conventional healthcare services such as rehabilitation.
Our human musculoskeletal model is designed according to a robotic way. The human bones and muscles are modeled as mechanical, so we can apply robotics computation for human kinematics and dynamics computation.
We developed flexible and wearable devices like touch-lock sensors, which can measure humans' muscle activities for 24 hours. We are also applying video-based motion capture system to measure humans' natural behaviors continuously.
We are working on a skill training system for restaurant staff to improve the quality of working. We can help people work on a healthy way, both mentally and physically.
Robotic caregivers could increase the independence of people with disabilities, improve quality of life, and provide support across activities of daily living. Tapo and his team at the Emprise Lab, is this correct, at Cornell are developing robots to do just that. Welcome, it's great to have you here.
Thank you for having me.
Tell us about the work that you're doing, that your team is doing to improve the quality of people with mobility limitations.
So our lab is doing various projects, but all these projects can be broadly categorized into 2 categories. The first category is targeting general robotic caregiving and democratizing the field by lowering the barriers to entry. So what do I mean by this? Basically, this field of robotic caregiving is impactful and people realize it, but still there are few researchers in the world who work on it compared to say some other robotic fields. So using these projects that I'm like this category of projects that are mostly in the we are trying to basically democratize this. Sparks enables roboticists to engage in a dialogue with these healthcare professionals and define or identify human caregiving problems and then translate it into robotic caregiving problems by physically structuring the field itself. The other line of category of projects are mostly towards trying to go deep and solve a particular activity of daily living, where we are trying to see how robots can help people eat if they cannot eat themselves. And so there the problem is the robots are trying to eat different, pick up different kinds of food, as well as feed people, not only in an individual setting, but also in a social dining setting.
Wow, that's very exciting.
Thank you.
And how can assistive robots alleviate challenges that face those working in the care sector?
Generally, when we think about assistive robotics, the first thing we think about is, they generally improve the quality of life of patients. So one of the fundamental challenges of caregivers in this field is that caregivers have a lot of burden when they actually help people with disabilities. And so our goal is to use robots not to replace the caregivers, but to assist caregivers so that it alleviates caregiver burden, and the robots can do the tasks and assist caregivers to perform this while lowering the burden.
Wow, yeah, Japan is really in the need of your team. What are the main bottlenecks in developing and implementing robots in the care sector?
For a robot to help a person do this task, it's a very challenging problem because the robots need to come very close to the humans, but also make sure that when to do these tasks, they have to physically come in contact with the human body. So they need to be safe and comfortable, and so that the person feels comfortable, right? So there is a lot of technical challenge there.
And how can we overcome those challenges?
So what we need to do is we need to involve these stakeholders from the beginning itself, so that people we already know what are the right problems to focus on, then how to design these solutions so that they can actually translate from the lab to the real world. So involving stakeholders is important. And secondly, I would say just having more and more researchers join this field, and that is why our projects of democratizing the field of robotic caregiving would hopefully play a role, because if more and more researchers come here, more smart brains come here, we can solve more technical challenges.
That sounds really impactful, yeah. And finally, what are you most excited about the future of caregiving, robotic caregiving?
I basically am excited because I see a lot of hope that it is actually going to be possible. I myself have seen over the years that initially we had these things, like there used to be isolated clusters of researchers, and they didn't used to talk to each other, and so there was progress, but to make meaningful progress, these different interdisciplinary groups need to talk to each other, and this is more researchers around the world are actually realizing it. And so there is a lot of focus on interdisciplinary research, which is the key to develop meaningful research or meaningful solutions for long-term caregiving in this field.
Thank you so much for being with us, and enjoy the rest of your conference.
Thank you so much. Thanks for having me. It was great.
As attendees from around the world are arriving at the venue, let's find out what they're most looking forward to at this year's conference.
This is my first time in IROS. Researchers are trying to participate, and they are sharing their knowledge. So that's good places to get together with the more research and research topics, especially people. So that's good experience.
The fact that it's in Japan for me is quite exciting, the opportunity, the skills to come and visit. But of course, coming here and seeing what other countries and other research groups are doing is also enriching.
So I was actually looking most forward to the workshops. The workshop I'm attending on Thursday is for swarm robotics, and that's an area of research that I really don't have much experience in yet, but that's what I'm going into. So I'm really looking forward to learning more about it.
So it's a great feeling to see all the people around and see all the wide range of different topics we can hear about, get to know really interesting keynote talks, very inspiring ideas. But then on the other hand, especially also in the workshop sessions, you got to know new PhD students working in the field that you can talk to, maybe thinking about collaborations.
And that's it for our first show here at IROS 2022. But make sure to come back tomorrow when we'll discuss the latest in AI-driven sensing technology, learn about robotics for extreme environments, and hear from women in engineering, inspiring creative growth in the field. Before then, you can watch the show here at ICC Kyoto. Find us on the IROS 2022 website, and don't forget to subscribe to IROS TV on social media. We'll see you tomorrow.